Hey, so today we are discussing Chapter 10, Section 4, which is entitled Inscribed Angles. This is a relatively short and easy section as it deals almost entirely with one new vocab word, that being inscribed angle. Now, we've already talked about central angles. That's where the vertex lies at the center of the circle. That is different. An inscribed angle is an angle in a circle whose vertex lies on the circle and whose sides are chords. So if we look at this picture here in circle A, angle XYZ is an inscribed angle. The vertex of that angle, Y, is on the circle, and the sides of that angle, which are chords XY and YZ, they're both chords. So it's an inscribed angle. The vertex is on the circle, these sides are chords. Just like central angles, inscribed angles intercept an arc, not necessarily a minor arc, an arc. In this case, angle XYZ intercepts arc XZ. Okay, so there is a relationship that exists between the measure of the angle and the measure of the arc, which we will get to on the next slide. In a circle, there are three ways that an inscribed circle can exist, or an inscribed angle can exist. They're shown here at the bottom of the slide. They're all based on the location of the center. Okay? For situation number one, we have the center lies on one side of the angle. So that's one possibility. In other words, one side of our inscribed angle is a kind of line segment is this guy right here. That is a diameter. So it is possible that an inscribed angle could have a diameter for one of its side lengths. Again, all diameters are chords, but not all chords are diameters. Yes? So it still fits the description even if one side of the angle is a diameter. The second possible system here is that the center lies inside of the angle. Okay, it's on the interior. And the third is that the center lies outside or on the exterior of the angle. Again, all three of these pictures show an inscribed angle. Okay? As long as the vertex of the angle is on the circle and the sides of the angle are chords, it is an inscribed angle. Okay? Doesn't matter where the center lies, it's still an inscribed circle. Okay, so the big thing in this lesson is that inscribed angles have a specific property when they're related to their inscribed, or into their arc that they intercept. It's called the inscribed angle theorem. So, in this picture here, angle ABC is an inscribed angle, yes? Okay, and angle ABC, which is an inscribed angle, intercepts arc AC. Would you agree with that statement? Okay, what this theorem says is that the measure of angle ABC is equal to half the measure of arc AC. So what I'm saying is, if angle ABC is x degrees, then arc AC is 2x degrees. The inscribed angle is always half of the arc. Okay, the inscribed angle is always half of the arc. Now, if we don't like fractions, we could write that as 2 times the measure of ABC is equal to the measure of arc AC. the same equation rearranged so that there is no fraction. The angle is always half of the arc for an inscribed angle. So we'll use that here in an example. It says use the inscribed angle theorem to find each measure. And in the picture, down there in the picture, we have that arc MN has a measure of 70 degrees, and angle PNO has a measure of 56 degrees. So the first question says find the measure of angle P. Well, angle P is an inscribed angle. Yes? So if angle P is an inscribed angle, it is equal to 1/2 the measure of the intercepted arc, which is arc MN. So the measure of angle P would be 1/2 times what? 70 degrees, good, which is 35 degrees. Done. Okay, it's a very simple idea. All we have to do is go the correct direction. Multiply or divide by 2, depending on what we're trying to find. Same thing for the second part. We have arc PO. Well, the arc is equal to twice the measure of the angle that forms it, in this case PNO. That angle is the inscribed angle that intercepts arc PO. Correct? So what we need to do is we need to take the measure of PNO and multiply it by 2. What's the measure of PNO? 56 degrees. So 2 times 56, or 112 degrees, is the answer for the second half of the problem. Not real difficult, yeah? Pretty simple idea. So how do we make it more difficult? That's an excellent question. Well, the short answer is that we will take algebra and we will embed linear or quadratic equations into the problems. And also, we will use our basic reasoning skills to expand out on that rule. So here on this next example, what can you tell me, what arc does angle T intercept? SV, okay? Angle T intercepts arc SV. Would you agree with me on that? Okay, what about angle U? What does it intercept? Oh, the same arc. So if they both intercept that arc, what can we say about those two angles? They're going to have to be equal, okay? Angle T must be congruent to angle U because both intercept, again it would help if I could spell, intercept arc SV, which means they have to have the same measure because they're each exactly half of that arc. Yes? So what we're going to do is we're going to say, okay, that means their measures have to be equal, which means 3x minus 5 has to equal 2x plus 15. This ability to write and solve an equation based on a picture is pretty much the whole point of geometry these days, is being able to apply our geometry rules to set up and solve an algebra equation. So we solve that for x by doing what? Okay, isolate the x by subtracting 2x from each side. While we're at it, what else should we do? Add 5 to get the numbers by themselves as well. That cancels, and we're left with x equals 20. Done, right? No, why not? Yep, got to read the problem. It didn't say find x. It said find the measure of angle T, which is 3x minus 5. And now that we know x, we can plug it back in. 3 times 20 minus 5 gives us 55 degrees for the measure of angle T. Okay? That's how we handle this kind of a problem. And that's how we supposedly make this harder. So on the second half of the page here, what do we need to do? With those measurements, again, same picture. Now we're talking about angle S and angle V. How are they related to each other? They're equal as well. Why? Good. The measure of angle S has to equal the measure of angle V because both intercept the same arc. This time that is arc TU in the picture. Okay? So same deal. We set those two values equal to each other. 3x equals x plus 16. And we solve for x. So we would subtract x from each side, which would give us 2x equals 16. And then we would divide by 2. So x equals 8. And just like the last problem, it's great that we know what x equals, but that doesn't answer the question, right? So we have to plug that back in. The measure of angle S is 3 times x, or 3 times 8, which would be 24 degrees. Okay, next up we have what's called the inscribed triangle theorem, inscribed right triangle theorem, which says an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So let's think about that. Okay, in the picture, does everybody see the center of the circle on line FH, indicating that FH is a diameter? Okay, so what this rule is saying is that if FH is a diameter, FJH, that arc, is a semicircle, yes? And it is being intercepted by angle FGH, which is an inscribed angle, yes? FGH is an inscribed angle. If it's an inscribed angle, its measure is equal to exactly half of the arc that it intercepts, right? Well, if that arc is a semicircle, what's the measure of a semicircle? 180. So angle G would have to be exactly half of that. What's half of 180? 90. So what this is saying is that angle G is a right angle if and only if FJH is a semicircle, meaning that FH is a diameter. Okay? Now how is that going to be applied? Well, it's going to be applied using, again, a property we should already know. Look at the example down here. What do we know about angle G in that picture? Yeah, it's intercepting a semicircle because FH is a diameter, yes? Which means angle G has to be 90 degrees. Okay, so what kind of shape is inscribed in this circle here? A triangle. And what do we know about triangles? Their three angles add up to 180 degrees. So that allows us to write an equation, angle F plus angle G plus angle H has to be 180, which will allow us to find the value of X, which will then allow us to find angle F. So we plug in what we know. Angle F is given to us as 4x plus 2 degrees. Angle G we've established is a 90-degree angle. And angle H is 9x minus 3. If we add those three values together, they have to add up to 180. That's a relatively simple algebraic example for us to solve. We start by combining like terms. 4x plus 9x is 13x. 2 plus 90 minus 3 is 89. And now it's a two-step equation. We subtract 89 from each side. Sorry. Which gives us 13x equals 91. And then we divide by 13 and we get X equals 7. Done, right? Oh, wait, yeah, we still have to plug that back in, don't we? So then we take the fact that x equals 7 and we use it to find the measure of angle F, which is 4 times x plus 2. 4 times 7 is 28 plus 2 is 30 degrees. Measure of angle F is 30 degrees. Okay, our last rule in this section is for an inscribed quadrilateral specifically. It says if a quadrilateral is inscribed in a circle, then its opposite angles must be supplementary. Let's think about that. Would you agree with me that all 4 angles in that quadrilateral are inscribed angles? The vertex of each angle on the circle? Are the sides of each angle chords? Yes, so they're all 4 inscribed angles. Now, look specifically at angle L. It intercepts what arc? MNK, right? Angle L, this angle right here, intercepts this arc. Yes? Do you agree with me on that? Okay. What about angle N, the opposite angle? What does it intercept? The rest of the circle, right? What do the pink and blue arcs add up to? 360. So if their inscribed angles are half of those measurements, what's half of 360? 180, which means that no matter what these 2 angles are, this angle N and angle L, they have to be supplementary. They have to add to 180 because they could combined intercept the entire circle. And since they're inscribed, they're half of their arcs. If their arcs add to 360, they have to add up to half of that, 180. Okay? So, let's look at this word problem down here. And one thing I do want you to see, and it's very hard to see even up here, angle C has a boxy. So make that more obvious, please. The necklace charm shown uses a quadrilateral inscribed in a circle. Find the measure of angle A and the measure of angle B. This is 2 separate problems. The measure of angle A plus the measure of angle D has to add up to what? 180. They are opposite angles inside of an inscribed quadrilateral. So our rule that we just established says they have to add up to 180. The measure of angle A is given, I'm sorry, not A, I'm sorry, I meant B. B and D need to add up to 180. Smooth. Let's fix that. I meant B. Angles B and D have to add up to 180 because they are opposite angles in that quadrilateral. So that allows us to set up an equation. The measure of angle B is given as being 2x minus 30. Measure of angle D is given as being x. If we add those together, we know they have to add up to 180. That allows us to find the value of x. Combine like terms. 3x minus 30 equals 180. Then what? Add 30 to each side. Gives us 3x equals 210. And then what? Good. Divide by 3. Should do that in a different color. Divide by 3. And we get x equals 70. Which doesn't really answer the question, does it? What do we need to do with that? Plug it in to find angle B, right? So the measure of angle B would be 2 times 70 minus 30, or 110 degrees. Sorry, I'm way down at the bottom of the screen here, I know. Okay? Angle B is 110. Now that's the hard part, because the same relationship exists between angles A and C, and angle C in the picture, and again it's hard to see, is marked with boxy. So the measure of angle C is 90 degrees. So when we do the exact same thing with A and C, it's going to go a lot faster and simpler because angle C has a boxing mark indicating that it is a 90-degree angle. So all we have to do is subtract 90, and we get that the measure of angle A is 90. So that finishes up that problem. Now there's one more problem on the next slide. I'd like you to try it on your own, please. Try it on your own. So if you're watching the video, pause the video and try it on your own and then resume the video. So we're resuming the video here and we're giving it a shot. So here's how we would do this. Again, WXYZ is an inscribed quadrilateral, which means that we have two separate equations here. The measure of angle W plus the measure of angle Y has to be 180 degrees. And the measure of angle X plus the measure of angle Z has to be 180 degrees. So what we do is we go and we plug in what we know. Okay, in this case, angle W is 95 degrees plus the measure of angle Y equals 180. That's a real simple solve. We subtract 95 from each side. And that gives us that the measure of angle Y is 85 degrees. And then we repeat those steps with the other set of angles. Measure of angle X plus the measure of angle Z, which we know is 60 degrees, equals 180. And then we subtract 60 from each side, giving us that the measure of angle X is 120 degrees. That does it for section 10.4. Thank you for your time and attention.